I work for Palomino, DB, which is sponsoring this meetup as well. We do mostly MySQL and PostgreSQL stuff. We have two different teams to work on a database. We are remote DBA, so we are basically caring about the DBA while developers is focusing on the development. We work closely, like integral part of the company. So we do performance reviews and we do daily checks to make sure everything is running smooth. And I actually went from today. Early today. I was in San Francisco doing an on-site for one of our customers, which is running MySQL in the cloud, RDS. So I was focusing on the MySQL and Sphinx for a long time. I was working as mostly I did very tiny development with Sphinx. I did mostly integrations, not the core core programming, because it's done on C++. So I was working as a consultant, as a performer at Sphinx, and now I joined the Palomino team, which is great. So let's get started. What is running MySQL like day to day? It's lots of operations. You have hardware faults. You have some bugs in the servers, in the server code. You have lots of issues you need to make sure that application runs smooth. And basically, the main thing is the whole lot of workaround environment is just all the routines can be somehow automated. Like when you run in MySQL by yourself and you're trying to scale something, there is a traffic spike comes in, and marketing folks warn you about that. Okay, we will double traffic in like a few weeks. What do you have to do? You have to get new hardware. It takes time. You have to install it. You have to test it. You have to get into production, and it takes a lot of time and effort for a DBA team. Running, you need to set up monitoring. You need to have a backups. You need to take care of them. You need to check if they are in place. Then, if you are a good DBA, you try to restore from the backup and make sure they are really work. And there's a whole lot of stuff you have to do by yourself, or you have to have several people who cares about, especially if you have big data. One thing I'd like to know from you guys: how much data do you run? Who's running more than 10 gigabytes database? So you know what I'm talking about. Once you have a lot of data, it's more and more complicated to run this stuff. So the RDS is pretty much replacing all that routine stuff that can be done pretty much automatically or sometimes automatically. And they call it relational database service. They have everything in place. The backups, the monitoring, load balancing, and as we talked before, while grabbing some pizza, there is automation. There is a whole stack. There's automation tool that allow you to script how you can deploy a cluster, basically, and then all the alerting system, monitoring system, backups are in place. So what you need to do to create a MySQL instance is just have a few clicks. But apparently it's not that easy. So there is some drawbacks in everything. So the idea of this talk is just walk through key things of what RDS can do and what RDS can't. You can create MySQL instance like with a one click. Once you fill it out with data, you can create another replica. Then you can create like the whole cluster. You can tune it up. You can take a backup whenever you want. By the way, I will publish the slides on the web. So if you caring about just taking pictures, I will give it to you. No worries. So it's very convenient. It's very convenient to have someone else to take care about the day-to-day stuff. So you don't need to worry about the hardware failures, because if it happens, and it happens, it's kind of the image transfers automatically to another box, backup image, then point-in-time restore performing, and then you have all your data back, or almost all. Depends on how bad was the crash. You don't need to worry about monitoring, because there is CloudWatch, and it will alert you the way you want, and you can set up several whatever you want on top of it. You have basic graphing. You have pretty much all you need for the start, and it's really helpful. It's really helpful. But there is always a drawbacks. So what is RDS? RDS is basically MySQL that's running somewhere. You can connect to the MySQL, but you can't connect to the box, which is where MySQL is running. So you can't SSH there. It's impossible. You can't have any information about the hardware background or anything. It's just hidden behind the walls. What you have is a window where you send in queries and getting replies. That's basically it. You still have all the statistics, MySQL statistics. You can tune it, but it's still you need to do it differently. You don't have access to the binary logs. So once replication crashed, you can't do like OK, change master to, and that's it. No, that's impossible. You can call stored procedure, which is do one statement, skip one statement, and hope that there is no other issues. Sometimes when MySQL crashed on the master and it doesn't close binary log file properly, and the event didn't went through to the replica. When master restarted, apparently you have no replicas. You need to create them one by one again, and the creation time depends on how much data you have. So. And you can create several replicas at the same time. I think it might be changed some time later, but right now that's impossible. So you can have cross-region replication. So once you decided to move from US East to US West region, there is several regions that you can create instances. You'll be unable to just create a replica in different region, then move all the data, then promote it as a master, and use that. No, that's right now it's not possible. So you have to do the tricks, like figuring out which tables are updated quite often, which is steady, dump the data, and somehow synchronize by yourself the data. Of course, it will be downtime to the move. We actually did it, Palomino actually performed that kind of move from one region to another. But we met RDS guy recently, and he said that RDS actually working right now on the cross-region replication. And the thing is that we had a talk on MySQL conference, which was like a week ago, and we were talking about what we saw in the real production, real customer production system. And the RDS guy, another RDS guy, stands like every 5 minutes. He stands up and said, "That's not true. We deployed it yesterday." So they really have extensive development, really, and it's really good to have a good RDS, a good team on the back of the RDS. They're trying to improve it continuously, but still there is some drawbacks. So how can you manage the replication? How can you manage the RDS sort? You can choose the region. You can control MySQL settings by yourself. It's available for you to change like pretty much not anything, but most of them. You can select RDS instance type. Amazon provides a lot of types for you, for your convenience, from very small to very large. They have their own network security stuff, which they promoted right now to use by all customers. And you can select storage, which you can run which you can use on the top of MySQL. So let's get in some details. There is several regions available for RDS, not actually for RDS, but for Amazon cloud services in general. Main is East region. It's kind of overloaded right now. They have a lot of infrastructure built in US East 1. There is several West regions, and I think prices might be different. I'm not sure, but they are. I'm not doing like pre-calculations. I'm just technical guy, so I think they are different. Yeah. So, and they plan to create several few more regions later. And I heard about Germany. Maybe there is some others, but they plan to extend it. 1 second. We have unpredictable technical issues. Besides regions, there is within each region there is availability zones, like A, B, C, D, E. I don't know if they're same in each or just different. What mean availability zone? Think of it as about data center. Like if one data center will die, which happened to US East before, then another data center will stay up, and so you can continue your operation. So yes, you will lose half of the replicas, maybe some of the replicas, some of the masters. You have to deal with that by yourself, recreate replicas on the live availability zones, but still, this is a way to survive somehow. And you can create actually master server, MySQL master, that based on several availability zones. How it works? There is the RPD replication on the top of it. So they have one instance alive, active, and one standby. And they constantly pass the data from active instance to the passive one. That's how it works. At least that's what we were told. One thing with RDS is you will never know. How can they do that? This is a highly, I don't know. It's a secret. I don't know why they don't want to tell us something like which scheduler they are used on the operating system to talk to the disks. It's all secret because someone else can steal it and create another bright and shiny Amazon cloud. So sometimes it's not helpful to have even master in several availability zones because replicas could die anyway. So replica outage is one of the classics, at least in my experience. Of course, and this is a disclaimer, I might not understand what RDS is. Some other guys can have, especially who work for Amazon, can have a different experience with that. But in general, that we have several customers who uses RDS, so we somehow need to survive here, and that's what we experience just in person. So for the storage is another big thing here. There is two types of different types of storage. First one is a EBS, and second one is a PIOS. They are called pretty much the same, but they are very different. For EBS volume is just a disk, which is somewhere in the network. At the top of this disk, there is a memory cache, so writes could be very, very fast, but at the same time, reads can be quite slow. PIOS is absolutely different. They use SSD for PIOS. So once you get yourself PIOS enable PIOS disks, which is provision, they call it provision PIOS. So you can buy a guaranteed number of the I/O requests per second. In this case, it will be SSD without any memory caches. So it's kind of more reliable, and of course it's faster. They might did some tunings on the MySQL side to match, actually, to force MySQL to use 4 kilobyte blocks to write, but it's so. And the thing is that all the disks are attached by the network. They have really fast network, but still you can have some troubles with that. Network could die. So speaking of RDS sizes, this is a list from the Amazon website, and you can grab anything from MicroDB. But for MicroDB, I don't think you can have provision PIOS disk. Someone told me about the limitations. I'm not sure, but still. And what we actually use, because we're mostly working with large data sets, like 50 gigs and more. So we use mostly the last one, which is biggest one. It has like plenty of memory. 64 actually, it says 68 gigs. I don't know why, but still. They limit I/O operations for small nodes, I think. And within every node, there is a limiter. They limit the number of I/O operations per second. They limit number of network operations per second. They limit number of they limit CPU time, and we don't really know how they do that. Of course, they have to do this to ensure that your neighbor will not eat your CPU just constantly. But at the same time, you may hit some issues when you try to do some like big massive operation, like massive write, and you can see some kind of weird spikes. That might be caused by the limiter on all stages. Okay. How you can control the RDS parameters? You can't just go ahead and say set something equals something on the MySQL side, and you don't have access to the config file. So you have to go to the console, or they have actually great tool set which allow you to change any parameters to create instances. So it's a great API. You can automate pretty much anything. You can copy parameter groups. You can change them. You can create instances, shut them down, using just plain communications with Amzon API. I use it for Linux. It's very convenient. You can check what's going on. You can check alerts out of the RDS console, just in command line. This is very convenient. But anyway, you have to go either way, via the API or via the console. You have to tune the parameter groups just like you tune MySQL, but you don't have access to the config file. So it's pretty straightforward. And the thing is that once we hit the limit of the parameter groups, so we file the case to the RDS, and they increase the amount for all the groups for us, but it still takes some time. So once you change something, you need to apply the changes, and if it's required to reboot, you just rebooting them, as some changes are not dynamic. That's basically it. This is pretty much the same as a general MySQL, except that something you can change, like I think transaction log size you can change, but again I'm not sure. So what's the general idea of the MySQL in RDS? What you have to keep in mind when tuning MySQL. You can benchmark your changes, your configuration, because when you run benchmark for the first time, it will be on it could be on one hardware. Then, when you reboot MySQL to make it cold, to perform really good benchmarks, it can go to the other hardware, and the results will be different. And again, they don't tell you, RDS support will not tell you what was going on actually on the hardware side. So you're kind of doing blind guesses. Of course, you can calculate I/O throughput based on the graphs that they show you. There's tools you can still can collect all the metrics from the MySQL side, and so you have pretty much enough information to do tuning properly. But sometime, in some point, they could change something in the code or in the hardware side, and you just have to watch on your MySQL installation. So what we do actually, we do daily checks. What's going on? Is it okay? Is it something is changed? Some guys monitoring what's going on the RDS announcements. What will be changed? When? How? Because they kind of, okay guys, we just create bright and shiny features which you guys will love. So this change will go into production in 2 weeks. Okay. Apparently some systems will not benefit from this change, but you have to deal with it. That's a drawback. So this is basically key thing for I/O. Sorry. So for I/O stuff, you have to remember that once you do write operation on the disk or read operation, it's not the physical disk. It's somehow the data store which located somewhere not near you. So it's involved network round trip, plus it involves discrete or writing into the cache. And well, we know that PIOPS should be SSD. We know that non-PIOPS EDS volume should be just a regular SATA drive with some memory on the top. But what exactly is that? We don't know. So we kind of rely on the Amazon team we trust them, and just trying to calculate on the information they provide us. So when you tune in MySQL, consider the worst case. Worst case in terms of performance and available resources. So in general, we are limiting capacity, INDB capacity. So INDB will understand that something is not fancy on the disks, especially on EBS volumes. For BIOS, you can have pretty fast. We are sometimes when application allows to if 1 second of the data is not critical, we relax in flush lock a transaction commit, and just generally, and it really depends on the data you have. So and the query you run. So it's hard to say that, okay guys, this is a list, just go ahead and implement it. For each instance, it will be the list will be different. For each workload, settings will be different. So it's quite hard to say, okay guys, go ahead and do this way. So you need to know which query you run, which data you have. So just like I said, do monitor your stuff when you on cloud, because something might happen, and you need to be prepared for this. So be prepared for replica outages. Be prepared for some kind of faults. Have a load balancer on the top of it, and this is like real world. Each box can fail, but in this case it will be a little bit different. They will handle all the hardware issues, but you need to deal with the rest. You still need to do that. It's not like RDS team will cover all the database stuff. That's impossible. They do pretty great job, by the way, to create environment which detaches you from the hardware and allow you to scale. Like when you expect a spike every noon, you can automate creation several replicas. You can create several replicas few hours before, handle this spike, shut them down, and save the money. That's really great. You just need to understand the drawbacks. So this is basically it. Instead of some improvements they do, they constantly improving that environment. They created right now, like a few months ago, they didn't allow to rename instance. Once it's created, it can be renamed. Now you can do that. Small things, but it's improving. There is they saying that microsecond precision should be in place. Today they told me. Didn't check yet. Anyone work with this stuff? Okay. So logs are now available from the console, both MySQL error logs and slow query logs, which is awesome. And well, there is a lot of stuff behind that RDS which they not published. So that's why they try to keep everything in secret so they can move forward and be the best. Probably that's an idea. So when you would like to use RDS, when you can split, if you can split your data to relatively small parts, so replica creation will be quick. And in case of outage, you can get your backup very fast and fire up an instance. This is a good thing. Then you can rely on RDS pretty much. Okay. When you can't really say which load will you have tomorrow, so you need to be scalable as hell. Like, okay, guys, next Monday. We will have a lot of visitors, and especially it works for game companies. When they release something, there's a huge amount of users downloading the game and start playing, and there's a really big spike. We have experience to handle like 100 times spike on the traffic using RDS, by the way. So sometimes it's convenient. Well, and actually, when you don't have DBAs and you don't want to think about the environment, RDS gives it to you for some price, of course, but still. They allow you to run everything just by clicking somewhere. You have a question?
Yeah. Sorry, apologies if you already.
No. That's okay. Just
if I wasn't listening properly, the first comment about keeping it sharded, Can you just elaborate a little bit on that?
Yeah. So let's think that you have a really huge table, like users table, and it's like 100 gigabytes. And you really, it takes a lot of time to back it up, to restore it, and if you're thinking about altering this table, it's just like, okay, let's do it later, because it's really huge. And in this case, what you can do is to change your application so that way, application will know that there is not one table, but like 10 or 16 or 24, which can be located in different servers. And you know which user, where it's located. So for each user, you know the server ID, and by the server ID you can have actual IP address, where to go, where to look. That's how it works basically. If you can shard your data, so it will be in smaller parts, it will be much easier to keep it working. Like imagine you have one server with that one huge table, with one huge database, and it went down. You need to restore it. The whole system is down. If you have one of 10 shards down, well, let them wait. It's really not that big problem, because website is still running. Customers are, most of them, happy. And for that 10%, well, it takes a lot less time to bring their data from the backup and make them happy.
Does RDS or Amazon provide any tools? I'm not aware of any that help you in sharding or scaling.
They provided us. We are Amazon partner. we can do automation. Like, okay, this part of table goes to this server. Right. This part of table goes to that server. Well, if everything will be automated, and I'm sure Amazon RDS will do that at some point, maybe in 5 years, I'll go retire. Because, well, everything is automated.
Yeah.
So when you choose a strategy, like when you do the partition, when you do the sharding, how you choose between sharding and the partition?
Well, partitions, it's the same table.
Yes.
On the same
Server.
On the same server, yeah. So sometimes partitioning is much easier to do, because MySQL handles that on itself.
Yes.
So if you see that your table is too large, and you need to deal with it, but you're not ready to change the application yet, because sometimes it's tricky.
Yes.
It depends on the development process. You can say, okay, in one team, okay guys, we have like test case in 2 weeks. Let's do that. In other teams, it takes a while until the idea goes to the code. So the partitioning is simpler, but it doesn't box went down. There's still other tricks, like okay, we can switch to the replica, we can promote it to the master and handle the load, but it's different approaches. Having all the data in one server or spreading the data across several ones, it's kind of different. It depends, and really depends on your needs and application.
Is RDS handling automatic failover for you, or do you have to do that yourself?
I'm not aware of it. So once we have something happened on the master, and we see it when it's down, we go in and getting up promote a replica and do everything manually.
And that's done through their GUI or through an API?
There's API tools. You can do it with GUI, whatever you like.
So you still have to have a server running somewhere checking stuff if you want to automate it.
There is CloudWatch that can send you alerts, and we have in general we're setting up our monitoring just to make sure that we have everything that we need and do not rely on the Amazon cloud, because with the Amazon cloud you can't configure it. I mean the thresholds, the time thresholds, like how it works. It checks every minute. If server is down, it checks, it starts timer.
It is you or it is Amazon?
No, it's Amazon.
Amazon, sure.
Amazon, yeah, Amazon CloudWatch. That's how we've been told. So it checks every minute, and it takes 1 more minute to make sure that server is actually down. Then it triggers alert. So for some cases, we need to check more often, like every 15 seconds, and make sure that if 2 checks didn't pass, then trigger alert. Because, well, okay, for Palamin we have coverage 24/7. We have US team, we have European team, so we don't need to wake anyone up. So the reaction time is pretty fast, and it's not like, okay, I need to wake up, get some coffee. Okay, what's going on? Oh, it's down. Shit. It's like, okay.
Fun out of being a DBA though.
Yeah. It's like, okay, something happened. Let's see. Okay, the monitoring is showing. Most of the alerts will appearing like, okay, it's just false positive. Sometimes they are false positive. Sometimes they don't. And in this case, we know how to deal with it and just. But basically, the key thing here is to have a process. Once you don't have like thousands of types of alerts, right? You have several key alerts that you need to know how to react on. Even if you like dead, you just okay, alert this type. We do this and this and this. We're doing checks, and we're getting things back to the production state. So, any other questions?
So if they just pretty much monitor if your server's down, you can't connect to MySQL or anything else beyond that. Is that for Amazon CloudWatch for monitoring RDS instances?
Amazon monitors several. There's a lot of parameters you can monitor, like CPU usage, swap usage. We out of time?
Go on.
So there's a lot of parameters actually.
You can cut it short.
Thousands. You can do whatever you want. But in general, we prefer to have our own monitoring, which can monitor availability, query runtime, that makes sure we not only can connect to MySQL, but MySQL will reply on time. Because if MySQL is overloaded, well, we can connect, but still it's not working. So it's kind of just several types of checks. Any other questions?
Aggregation means in this context always master to slave aggregation or also master?
For Amazon RDS, it's only master slave.
Yeah.
They run. You can create multi-AZ master, which is 2 instances in different availability zones, and 1 active, 1 passive, and you have somehow they say this is the RBD, but this might be different too. Somehow it passes to the passive one, and once we have a failure, we still have standby instance, but still
So what you can really scale is just the reads, not the writes. So if you have an application, all the writes have to go to the master, and then you can scale
Right.
the reads.
Right, but it's a general combination. So if you want to create setup where you can write to pretty much every instance, there's Galera, and you can do that. You can set up Galera on the top of EC2 and make it work. So setting up MySQL on EC2 is pretty much different topic.
Yeah.
It's still MySQL, it's still on the cloud, but it's different because you are controlling things there, and there's some drawbacks because you in this case we have to do all the backups, all the monitoring, all that stuff, all replication setup.
So still in this context, so you have a master, you have lots of slaves, and then you have a load balancer sending the read queries to the different slaves. That's the typical use case.
Right,
And
right.
the load balancer, is it like database diagnostics, so it's just a TCP load balancer, or is it?
They have a route 53, which is DNS stuff, and you can use it to the balance load. It's all in the Amazon services. You can set up your own, whatever you want.
But it's, what I mean is that it's not really balancing the queries, it's balancing the TCP connection.
Yes.
So it doesn't know
Right.
if one slave is running like lots of happy queries, so it might send another connection to
Well,
the
the
other one.
thing with bad queries is the following. If you have bad queries, you have to spread them across the all replicas in very consistent way. So in this case, all the load will be consistent. I'm kidding, of course. If you have bad queries, you have to deal with them, you have to fix them, instead of load balance them, right? Yeah, so, good.
I had a different question. I read some stuff online about how kind of before provisioned IO ops were available, that people would take EBS devices and put a lot of them together into software RAIDs to kind of get better performance. My question is really, do the provisioned IOPS make that obsolete?
I would personally, in my little world, I would go with provisioned IOs. Because it's faster, because it's faster. You can play with EBS volumes. Yeah, you can create a RAID mirror. You can create RAID 10. You can create whatever you like, but it will cost you some money, and it will still be network round trips. So, and here is the thing. This is a kind of very good question because it creates a discussion. When you do a RAID of the EBS volumes, this is not hardware RAID, it's a software RAID. And this RAID, utilizing network exchange. And there's limiters. So once you write in some big amount of data, and this amount hits the limiter, you can have and the RAID software RAID can react like it can wait until the last request will be completed, so you can have some fun with the IO subsystem.
It seemed like the software RAID was a hacked solution that people had put together to get around some things before Amazon came out with provisioned IOPS. So it seems like it really is kind of a hack that you would want to avoid if possible.
Well, I don't really work with the EBS volumes because I work mostly with RDS, so it's kind of hidden, and I don't really have access to the to see what exactly going on there.
Okay.
So, but in general, in my experience, provisioned IOPS works much better in RDS side.
So there's another meetup we had where they actually mentioned that Netflix is probably using all the SSD instances instead because it's more cost effective.
Yeah,
And you get more performance per instance.
got it. That's good to know.
Who spoke at home?
I'm trying to remember. It's like, yeah, I've gone to some meetups, comes to blur after a while, kind of like very context nowadays. So it was actually a really good talk. You look, or you search on it, you might find something out there.
Cool, because Adrian Cockcroft gives great talks, you might bring him over, but. Yeah. Sorry.
Any questions? Got it.
Yeah, I have a question. Do you have any recommendation, like as a memory to basically database size ratio? Is any consideration from your side?
Well, do you hear the question? The question is, how much memory I would recommend to have depends on the amount of data. And this depends on the data usage. If you just writing down the data and do not read it, you can have a very small amount of memory, just to use it as a buffer to read, to write, sorry. If you are reading all the data at once, like you are using full table scans, whatever you want or not, just in some application you have to use it. You probably want to all the data fit to the memory. But general case is in the middle, when some data called hotspot,
Yeah.
which is frequently used, and the main thing is to keep that hotspot in memory. Once it's in memory, you are safe. But there is a tricky stuff. As your data grow up, at some point you can hit the situation that this hot data
Yes.
do not fit in memory anymore. And in this case, you have spike on the I/O usage. So how to prevent it? Just to see the query used, just to and trying to understand how your application works, how much active users you have. Like you can have 2 million active users, but at the same time, you can have like 100 million users in general. So, given that information, you can calculate it.
I see. Actually, our application is not like consumer facing, so it's not that sensitive to the time, to the response time. So I got your point. So basically, the hot data is better to get fit into the memory.
Yes, at all times. And the thing is that you need to calculate your cost. So the memory is quite cheap right now. So you need to walk through all the instance types and just calculate how much money you will spend if you have a little less memory but faster I/O, or just in the opposite, more memory with slower I/O.
Yeah.
So it's always drawbacks.
Are all the storage, the most used storage engines like InnoDB available under RDS?
InnoDB is available.
Yeah, and you can change the buffer size.
Yes, you can change buffer, InnoDB buffer pool. You can configure pretty much everything. There is some settings that you can't configure, or it might be some settings that you can change, but they might not affect the MySQL. We never know.
One unrelated question. I know that this talk is not about running MySQL on EC2, but that would be another option.
Right.
How would that compare to RDS? Maybe if you can say a few words. I know that's a huge topic.
Well, I personally don't have much experience running MySQL on EC2. I can get back to you in 1 year and let you know. So this is basically it. So yeah, exactly. So you can use the EC2 with a MySQL. You can put Galera. You can use Tungsten, and Tungsten. In case of Tungsten, you can use it to migrate from RDS to the EC2 instances. So it's pretty much. There is other ways. Something wrong with my laptop. Questions?
One more. Are you familiar with Redshift? That's also an Amazon service, but for like data warehouse, calendar.
No.
I'm looking now at that, and it's for it. It has the same advantages and disadvantages like this one. So it's another database basically by Amazon as a service.
Yeah, and there's a Oracle representative, so you can talk about the Oracle in RDS, because there is, besides the MySQL, there's Oracle stuff as well. So thank you. It's all about MySQL.
Yeah, having to do with like the hard, you were saying that your benchmarks might be different because the hardware
Different hardware, yeah.
changes, but you also said that, I mean, isn't Amazon guaranteeing the CPU?
They
the
guarantee
IOPS,
you, yes, they guarantee you.
So are you
some-
guaranteed some minimum?
Yes.
So you might be faster than that, but if you just say, I'm guaranteed this.
I don't think it will be faster than that, but the thing is that hardware might be different, and they guarantee you some kind of calculation units, like CPU units, CPU time. But CPU time might be different in case of different, each CPU can have different speed, different cache size, right?
Don't they tell you those specs?
No.
You don't know how fast
Why?
your CPUs are?
Why?
Well, they're virtual. I mean, it's all
It's
right.
virtual. You have
Right.
a
So
bright
you're
and
saying-
shiny virtual CPU.
You know, it's a virtual 2.2 gigahertz or something?
Well,
What did they say?
the thing is that whatever they say, at some point you can wake up in absolutely different hardware, and you can wake up at some point with a different network structure. Like latency to your disks will be different. The throughput will be the same. Throughput is guaranteed, but latency will be different.
What's guaranteed?
The throughput, how much megabytes you can pass through the network.
Okay.
But they do not guarantee you latency time. How fast turnaround is.
I mean, isn't that your IOPS?
It's an IOPS. It's number of IOPS you can do at the same time. But number of IOPS it's in several threads, and number of IOPS in one thread is different. When you send in IO request and waiting back, and then sending another, is different than you send 1, 2, 3, 4 and start waiting.
So what's the spec that they give you when they say we guarantee 1,000 IOPS?
At some point, you can have 1,000 IOPS. At some point.
It's your maximum?
I don't know. I'm not an RDS guy.
Right.
So
we're just saying, your maximum is going to be this, and you can go to 0.
I take it as follows. At some point, if you're lucky, and there is not very cloudy, you can have this number of IOPS.
There's no guarantee.
Disclosure any hardware specification. They do not disclosure any software specification.
And there's no guarantees on any of these specs.
How can you check it? You need to benchmark it, right? How can you benchmark? How much IOPS did your database use while writing data? IOPS, how large is IO? 4 kilobytes, 16 kilobytes, 5 bytes.
Right.
It's all different.
Well, but you can definitely, these are numbers that you can count. I'm not sure what you're saying.
It's tricky.
As soon as you virtualize
The question
stuff,
isn't about, whether
Using
how
the cloud
hard it
is
is to,
not-
how hard it is to benchmark stuff. The
Look,
question is
for
whether
real
guarantees-
hardware, you can calculate. Okay, this is 4 disks, right? There is a memory on the top of a controller, and you do have each disk running like SATA drive running 200 IOPS per second. Okay, and so in general, with the rate 10, we can have like guarantee 400 IOPS, right? Two disks in parallel and two disks in mirror, right? You can calculate it. It's tricky stuff. It's simple stuff. Sorry, but when you use network at the top of your hard drive, and you don't know even model name, you can't really calculate something. You can benchmark, but once you reboot your instance, it can appear on a different hardware, so your benchmarks will not be valid.
More than that, our benchmarks are all based on time.
Right.
Have you ever heard of time drift on VMs? So if the time is drifting on the VM, how do you know what the actual accurate time is?
Stopwatch.
Right. So it really comes down to, if you've got a hardware crystal, you're actually basing your time based on the crystal. But now VM is pretending it's got a software crystal.
Well,
and
what
it
I don't care
comes out
about-
always on time. And especially when you get into the really tiny microseconds, it's really hard.
That's not the part that I would care about as a user, though. What I
Yeah,
would care
because-
about is I have some operation that if we were to compute with a certain IOPS and a certain amount of CPU
Right.
power and a certain amount of throughput and a certain amount of
But
latency,
still,
it would take this much time, like 10
what
minutes.
clock are you using to measure it?
It coming back to me. It takes 2
When?
days as
When
opposed
it
to
comes?
3 days.
When it
I'm
comes
not
back,
talking about microseconds, I'm talking about bulk. That's how you get the average IOPS.
what would you do? It's all different microseconds.
What's that?
What would you do? It's all different microseconds. If it's software clocks.
No, I'm talking about a much higher level, like.
No, what
I
you're
just wanna
saying
know
is
what-
that-
I want Amazon to guarantee me some average performance.
It is. You have guaranteed performance. You just can't measure it. So think of it as about the nice numbers. So that nice number will give you approximately ability to write that amount of megabytes per second. Another nice number will give you ability to write twice more megabytes per second. That's all it is. So somehow it compared to the real IOPS on the hardware system. But again, it's hard. It's quite hard to measure.
Amazon actually does a really good job compared to internal IT departments provisioning stuff. Trust me, it's like, you watch some of these larger companies that got these large VM infrastructures, they're way oversold because they got a limited budget. Whereas Amazon, they'll try to give you what they specify to their best ability compared to the internal stuff. So I mean, it's a hard thing to measure, but in the end, it's all of us coming together and expressing our experiences with Amazon that keeps them honest. Compared to some of the other players.
I guess the other question I had, totally unrelated, was so let's say you have your master and you're using it. Typically, you might want your slaves to be much weaker because they're not, they don't need to do nearly as much work.
That's yes and no. That's yes and no.
If you're doing a lot of inserts, for instance.
Yeah. Well, the thing is that every slave will be applying changes from master in one thread. So you need to have a good CPU there.
Well, but you might be. Let's assume that you have a system where the master is working much harder than slaves. Well, then, how do you deal with the provisioning of masters, like backups and backups? Do you have to have all your slaves, or like 5 slaves, all be the same size as master, or does Amazon maybe mitigate that somehow?
In terms of backup, Amazon creates them without utilizing. I think I don't think they utilize provision types to take a backup. It might be. I think it's on their own expenses. They create an image, put it to the S3, and then they collecting all the binary logs to perform point in time recovery. So in general, think about this as like virtual. It's really virtual machine that runs MySQL. So you can buy not a real IOs. You can buy not a real CPU. You just buy some kind of CPU, Amazon CPU, and Amazon IO. So it might not be related to hardware. It's just Amazon one.
I guess another way of asking this is, can you upgrade an instance without having to rebuild it?
I don't think so. For RDS, you need. I'm not sure. I'm not sure.
I think RDS you can upgrade if
You
it's
can.
if it's on demand, then you can upgrade on the spot. So basically, the console you can do it.
So you can
But,
say I want more CPUs on this instance?
Yeah, you can basically change the instance size, whatever the instance
That's
type. But once it's reserved, once you get a reserved instance, you can do that. Yeah.